Hello and welcome to another video. In this video we're going to be working on find all duplicates in an array. And so it's kind of a similar problem to yesterday, but now you have multiple duplicates. So you have multiple duplicates and each number can appear once, 2 times, or no times. So what we can't do, for example, is like, let's say we have this. We can't just be like, if we see a number, like let's just mark it negative or something. Because like, that would be like one strategy. Like let's say these indices are 1 to n, so we could just say like, okay, if we see 2, let's mark index 1 negative, because like 2 would be index 1 and then 8 would be index 7 and so on. Because if you mark it negative and then you see it again, then you'll like mark it negative again and it'll be positive. I guess what you could do is like you could mark it negative the first time, and if it's not, and if you see it again, then you keep it negative. But then how would you tell if you've seen it once or twice? So that kind of strategy kind of doesn't work. And so the only way I've figured out to do this problem, well, the examples are pretty straightforward. Like you just give all the negative numbers, or not the negative, the ones that appear twice. But the only way I've figured out so far to do this problem is you do have to do some in-place modifications. And there's kind of a bunch of things you can do, but one of the reasonable ones I figured out is you can just look at the constraints. So because every number can be 10 to the 5th, we can just add some number to every number that we see. So let's walk through what that would look like for example 1. And I'll kind of explain like why that works. So let's just say this is 4, 3, 2, 7, 8, 2, 3, 1. And yeah, so the one thing we are going to do is when we see a number, like the index we're going to mark is the index 1 less than the number, because these numbers are 1 to n and our indices are 0 to n minus 1. So we're going to mark, we're going to mark like whatever index we have minus 1. But we also, because we're going to do some kind of modification, what we also are going to do is we need to do something reasonable. And we also, like, if we do mark a number, we need to be able to mark it to something that we can still use it for. Because like, let's say here, this is index 7, which would be index 6. We mark this, but we still need to use this later. So whatever modification we need to do, we need to be able to like revert back. And so one thing that I found that kind of works is you just look at your constraint. So your constraint is 10 to the 5th. So you can just take, like, if you want to keep your numbers as small as possible, you can just take the number right above this. So just 10 to the 5th plus 1. And basically what we can do is anytime we get to an index, we'll just add this to that index. And then at the very end, because our numbers are 1 to 10 to the 5th, every number that is bigger than 10 to the 5th plus 1 times 2 will be visited twice. And we can obviously always get back our number, because if we take a number and add 10 to the 5th plus 1 to it, you can add like 10 to the 6th or whatever you want, just something bigger than this. You can get it back, because if you add, like, let's say I do this, I add like this to 1, I'll get some number. You can just take whatever number you have and mod it by this value here. So let's call this value like big int or something, or b, this 10 to the 5th plus 1. So let's walk through now what would happen. Now let's make this a little bit bigger so we can fit everything we don't really need. Okay, there we go. So our ideal output here should be 2 and 3. So let's see what would happen. So we're going to go over here. We're going to take this number. We're going to mod it by this big number. It'll just give us 4. And then the number we're going to add this big number to will be at index 3. So we'll just say this is like 7 plus b. Okay. And then we're going to go to the next number. So this number is over here. So we're going to mark index 2, and we're going to add this big number to that. So we're going to say 2 plus b. And then here, like I said, whenever we go to a number, we will just mod it by this big number. So we will get a 2 here. So when we mod 2 plus b, modded by b, we will just get 2. And then we want to mark index 2 minus 1, which is right over here. So this is the one we're going to mark next. So this will be 3 plus b. And let's make an error just to know where we are. So we're over here now at our 4th number. So here we will mod it by b again. So we will have 7. Then we want to mark index 6. So this will be 3. Yeah, 3 plus b. Then we go to the next number. So this will be 7 plus, so we go to index 7, and this will be this number plus b. Then we come over here. So this will be 2 minus 1. So index 1, we will add another b. So now we have 3 plus 2b. Then we come over here. So we mod it by b, and we will get 3, and we subtract 1. So we want to mark index 2. So here we add another b. So 2 plus 2b. And then finally, the last one, we will mod it by b. We will get 1, subtract 1. So we'll mark this one over here. So every number that has 1b added to it appears once in the array, and every number that has 2b's added to it appears twice. So for example, so remember, and remember these numbers are like this 0 represents the number 1 because this is 0 index and our numbers are 1 indexed. So that means 1 appears once. So here it is. 2 appears twice, which it does. 3 appears twice, which it does. 4 appears once, and then 5 appears never, because there are no b's. 6 appears never, and then 7 and 8 appear once, which is exactly what we want. So then we just run through our array, check for every number that is greater than 2b, which is these two, and then we take its index plus 1, and those are our two numbers. So this will be 1 plus 1, which is 2, and 2 plus 1, which is 3, and that's our result. And so that's what we're going to code up. There's probably some other transformations you can do, but like just making the numbers negative, like I said, doesn't work, because if you make it negative and then you multiply by negative again, you go back to the original result. So let's code that in Java. So first we'll just make like a constant variable, like int big int or something, or we can call it b if we want to, I guess. And this is just going to be 10 to the 5th plus 1. So 10 5th plus 1. Okay. So now we're going to run through all our numbers, and we are going to do this thing where we're going to take the current number modded by b, and then we're going to take the index of whatever that is minus 1, because these are 1 index and we need it to be 0 indexed. So converting from 1 to 0, we'll just subtract 1, go to that index and add b. So let's do that. And then we run the loop one more time to get it. So we can say for int I equals 0, I is less than num's length. So our like index that we're going to, so we can call this like index, is going to be num's I modded by this b, because we might already have added b a few times to it. And it's going to be that minus 1, because we're converting from 1 index to 0 indexed. Then we can just say nums at index plus equals b. Then we run this loop again, and we have our result, or we want to list integer, so we can do list integer result equals new array list of integer. And we will just copy this loop again and change a little bit now. So we can basically say if nums I is greater than 2b, that means we've added b to it twice. That means it appears twice, because every time we add b, it appears. So if that's the case, then this should go in our result. So we can say result add, I believe in Java, we'll add nums I. And because we're going from like index 0 to the last index, this will be in increasing order. And remember, we don't want to add nums I, we want to add the index we're at, because that's the index that appears multiple times, plus 1. Because if these indexes are 0, we want to make it 1 index, so we'll do I plus 1. And finally, we can return the result. It's a little weird tabbing, or whatever, it's fine. So let's run this and see what happens. Okay, so it looks like we have an error. So I think our error is because this should have been 10 to the 5th, and this is 10 to the 4th. So now it should be fine. So it's too small, and then we were getting like something wrong. Okay, so there we go. Yeah, you can make this like, if you don't want to use this, you can make it like 10 to the 6th or something. Just something bigger than 10 to the 5th, or you can change the logic a little bit. But the basic idea is the same. You just add some number to represent that you've been here before. Yeah. And so this is going to be, and I don't see how you could do it without modifying inputs. If anyone knows how to, that's not some crazy solution that's like pretty ridiculous to come up with, let me know about that one. But another case, or yeah, so this is going to be of(n), because we're basically just looping twice, and space of(1), which is what they asked for in this thing. Yeah, I don't really see how you could do it in any other way other than modifying input, because like the tortoise and the hare stuff doesn't work when there's multiple cycles. and you can't find all of them. But yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.